Proof by induction. The purpose is to prove that equalities and or inequalities are true. Given a series and a formula, prove that the series equals the formula. Why? You check if the formula works for whatever value is given to n. These are the definitions. Given that you have to prove this, the induction method has two parts, the base case and the induction. The base case means giving n the smallest value in the series, which equates the series to 1 and then equates the formula to 1. So the series equals the formula, which proves the base case. The induction part has two steps. You first assume p of k, which means rewriting the expression using k instead of n. And you'd get this. You'd have to prove p of k plus 1. Firstly, you'd rewrite the expression using k plus 1 instead of k, and you'd get this. For the actual proof, you equate p of k plus 1 to p of k plus I. There you have it. pk formula to I. pk formula, you'd get it from here. I, you'd get it from here. It's just basically I equals k plus 1, and p of k is what we assumed previously. Now, to reach, I said here aim to reach the formula, which means just expanding on p of k plus I, and this would lead you to this. So your formula would be k plus 1 times k plus 2 over 2, and this is similar to this one, because your k plus 1 would be n, so this would be k plus 1, and this would be k plus 2, and then you have it over 2. You proved p of k plus 1. Prove that the series equals the formula. The base case, give n the smallest value in the series. So the sum would become 0 times 0 factorial, which is 0, and the formula would become 0 plus 1 factorial minus 1 equals 0, 0 equals 0, base case proven. The induction part. Assume s of k. Write the expression replacing n with k. Prove s of k plus 1. So you'd also write the expression using k plus 1 instead of n. You prove p of k plus 1 by remembering that p of k plus 1 equals p of k plus the common term, which you find it here, I times I factorial. Again, you'd take p of k from here and I from here. Therefore, p of k plus 1 becomes k plus 1 factorial minus 1 plus k plus 1 times k plus 1 factorial. So this is what you'll find here. and then you'd simplify until you reach this form: k plus 2 factorial minus 1. After you cannot simplify any longer, you look back here at the formula you have to prove, the expression you have to prove. So you have to think, can you write k plus 2 factorial minus 1 as k plus 1 plus 1 factorial minus 1? Indeed you can. So you've proven by induction that your formula holds for k plus 1 terms.